Ungrounding the secondary of a transformer, especially when feeding a UPS system, is a complex issue with potential implications for safety and equipment functionality. The National Electrical Code, or NEC, provides guidelines for grounding and ungrounded systems, but the specific application often depends on the load characteristics and the overall system design. In the situation you described, where a 480 volts primary to 240 volts secondary transformer feeds only a UPS load, and the UPS has external batteries and chargers connected to a DC bus, ungrounding the secondary could potentially address ground fault issues, but it must be done in compliance with the NEC. Let's delve into the NEC to understand the relevant sections. The NEC generally requires that alternating current, or AC, systems operating at 50 volts to 1000 volts must be grounded. This is covered in NEC section 250.20. There are exceptions to this rule, and one exception allows for ungrounded systems under specific conditions. These conditions usually involve ensuring that qualified personnel maintain the system and that ground fault detection is implemented. The concern with ungrounded systems is that a single ground fault will not cause overcurrent protection to operate. This means that the faulted circuit can continue to operate with a ground fault, and if a second ground fault occurs on a different phase, it will result in a phase-to-phase fault, causing a high current flow that could damage equipment and create a safety hazard. Ground fault detection devices are essential for ungrounded systems because they provide an early warning of a ground fault, allowing personnel to address the issue before a second fault occurs. If the UPS manufacturer is recommending ungrounding the secondary, it's likely based on specific characteristics of the UPS design and its interaction with the DC system. UPS systems often have internal ground references, and introducing a second ground reference point through the transformer secondary grounding can create circulating currents or other issues that interfere with the UPS operation and connected equipment. The NEC permits ungrounded systems under certain conditions, as outlined in section 250.21. This section requires that the system operates with ground fault detection, as just mentioned. The purpose of the ground fault detection is to alert personnel to the presence of a ground fault, allowing them to locate and correct the fault before a second fault occurs. Ground fault detection systems typically use sensitive current transformers to monitor the current flow in the grounding conductor. In a properly functioning ungrounded system, the current in the grounding conductor should be close to zero. When a ground fault occurs, a small amount of current will flow through the grounding conductor, and the ground fault detection device will trip an alarm or disconnect the circuit. Section 450.3 provides guidelines for transformer overcurrent protection. The primary side overcurrent protection is typically sized at 125% of the transformer's primary current rating, while the secondary side overcurrent protection is sized at 125% of the secondary current rating. These overcurrent devices protect the transformer from overload and short-circuit conditions. If the secondary is ungrounded, the overcurrent protection on the secondary side will not respond to a single ground fault. This is why ground fault detection is critical in these systems. Regarding the DC system and the potential ground fault appearing at the charger, it is essential to investigate the source of the fault. It could be related to the transformer grounding configuration, as the UPS manufacturer suggests, or it could be due to a ground fault downstream from the DC panel. If the DC batteries are tied to the UPS DC bus and the DC panel for motors and other loads, a ground fault in any of these components could cause a fault current flow. To troubleshoot the ground fault, firstly, isolate the DC system components one by one to determine which component is causing the fault. Secondly, use a ground fault locator to trace the fault current back to its source. Thirdly, inspect the wiring and connections in the DC system for any signs of damage or insulation breakdown. If the UPS manufacturer recommends ungrounding the secondary, it's crucial to verify that the UPS is designed to operate safely in an ungrounded configuration. Some UPS systems rely on a grounded secondary to function correctly, and ungrounding the secondary could negatively impact their performance. Consult the UPS manufacturer's documentation and technical support to ensure that ungrounding the secondary is an approved configuration. Additionally, verify that the ground fault detection system is properly installed and functioning. The ground fault detection device should be sensitive enough to detect even small ground faults, and it should provide a clear indication of when a fault occurs. Proper labeling is also important. The NEC requires that ungrounded systems be clearly labeled to indicate that they are ungrounded and that ground fault detection is in use. This helps prevent accidental grounding of the system, which could create a safety hazard. Here are some additional considerations for ungrounding the transformer secondary. Firstly, perform a thorough risk assessment to evaluate the potential hazards and benefits of ungrounding the secondary. Secondly, consult with qualified electrical engineers to ensure that the system complies with all applicable codes and standards. Thirdly, document all decisions and changes made to the system, including the rationale for ungrounding the secondary. Fourthly, train personnel on the operation and maintenance of ungrounded systems. Fifthly, implement a regular maintenance program to inspect and test the ground fault detection system. Here's a summary of the NEC sections relevant to this discussion. Section 250.20 covers general requirements for grounding alternating current systems. Section 250.21 covers exceptions to the grounding requirements, allowing for ungrounded systems under specific conditions. Section 450.3 provides guidelines for transformer overcurrent protection. It's important to understand that the NEC is a minimum standard, and in some cases, additional safety measures may be necessary. Consider the specific requirements of the application and consult with qualified professionals to ensure the system is safe and compliant. If ungrounding the secondary is chosen, ensure that the system is properly designed, installed, and maintained. Ground fault detection is essential, and personnel must be trained to respond to ground fault alarms. Periodic inspections and testing are also necessary to verify that the system is functioning correctly. Remember that the customer engineer's concerns about NEC violations should be taken seriously. It's important to thoroughly research the NEC requirements and consult with qualified electrical engineers to ensure that the system complies with all applicable codes and standards. If there is any doubt about the safety or compliance of the system, it's best to err on the side of caution and seek expert advice. Always prioritize safety and ensure that the system is designed and installed in a way that protects people and equipment. Additionally, consider the potential impact of ungrounding the secondary on other systems connected to the transformer. Ensure that ungrounding the secondary will not create any unforeseen problems or negatively impact the performance of other equipment. Proper coordination between the transformer, UPS, DC system, and other connected equipment is essential for a safe and reliable electrical system. The NEC is updated regularly, so it's important to stay current with the latest requirements. Consult the latest edition of the NEC and any applicable local codes or regulations. Also, remember that the NEC is not a design manual. It provides minimum requirements for safety, but it's up to qualified electrical engineers to design a system that meets the specific needs of the application. The information found on the Mike Holt website, as previously mentioned, can be a valuable resource for understanding transformer grounding and NEC requirements. However, it's important to verify that the information is current and applicable to the specific situation. Always consult the latest edition of the NEC and other relevant codes and standards. Also consider the long-term implications of ungrounding the secondary. While it may address the immediate ground fault issue, it could create other problems down the road. For example, an ungrounded system may be more susceptible to voltage transients and surges. It's important to carefully weigh the pros and cons of ungrounding the secondary before making a decision.